So example 3 takes a little bit more thought. So Josie can paint a room in 3 hours working alone. And Tiffany can paint the same room in 6 hours working alone. How long after Josie starts to paint the the room, will it be finished if Tiffany joins her 1 hour later? So I need to know what I'm trying to find. My X is the time it takes to paint a room. These ladies to paint the room. I know that Josie can, in 1/3 of an hour, she can paint 1/3 of a room per hour. And she's going to work on that room X hours. We don't know. It's the time it's going to take them together. And then Tiffany, well, it takes her 6 hours to paint room on room, so she can paint 1/6 of a room per hour. But she's not there the whole time. She joins Josie 1 hour later. So we're going to take away an hour. So then I have 1/3 x. If I multiply across, when we used to set these up for the word problems. And 1/6 times x minus 1. Well, that's going to all equal one room painted. This is the portion of the room they can paint, and we want one room painted. So if I have 1/3 x plus 1/6 x minus 1, that's going to equal one room fully painted. So when I solve for x, it'll tell me the number of hours. So let's go ahead, and I've got x over 3 plus x minus 1 over 6. I'm going to make these like fractions so I can add them. I'm going to multiply this fraction by 2 on the numerator and the denominator. 2x over 6 plus x minus 1 over 6 is 1. Don't forget that part. So I have 2x plus x minus 1 over 6 is 1. And of course I ran out of room. So let's go over here. I combine like terms, so I have 3x minus 1 over 6 is 1. 1 is a fraction is 1 over 1, so I multiplied both sides by 6. I get 3x minus 1 is 6. Add 1 to both sides. I get 3x is 7. So x equals 7/3, which is 2 and 1/3 hour. And that should make sense, right? It should definitely take Josie less than 3 hours to paint the room because she has Tiffany helping her. So it would take them 2 and 1/3 an hour, or 20 minutes, to paint the room. This last application is nursing based. So nurses use proportions to determine the amount of a drug to administer when the doses is measured in milligrams, but the drug is packaged in a diluted form in milliliters. So for example, the number of milliliters of fluid needed to administer 300 milligrams of a drug that comes packaged in 120 milligrams per 2 milliliters of fluid, you'd set up this proportion. So I know there's 120 milligrams in 2 milliliters of fluid. I need to administer 300 milligrams. How many milliliters am I going to have to have? Well, in order to do that, we'd solve for x. So let's go ahead and set up two different problems. Please enjoy me mispronouncing these medication names. I have no idea how to pronounce them. So if I have 120 milligrams of amikacin, and that's what I want to administer, but it's packaged as 100 milligrams in 2 milliliter vials. So in every 100 milligrams, I've got 2 milliliter vials, and I want to administer 120 milligrams, so I need to figure out how many milliliters. Now is when I cross multiply. I have 100 milligrams X is 240 milligrams times milliliters. Keep track of our units when we want to know how many milliliters to administer. That gives me X is 240 divided by 100 milligrams. My milligrams cancel. I get 2.4 milliliters. So that is the dosage I would need to give my patient. I'd have to give them 2.4 milliliters. Let's set up another example. So 1.5 milligrams of morphine, oh, I can pronounce that one, packaged as 20 milligram ampoules diluted in 10 milliliters of fluid. So I have 20 milligrams per 10 milliliters, and I want to administer 1.5 milligrams, and I need to figure out the milliliters. So I'm going to cross multiply. I've got 20 milligrams times X milliliters is 15, because 10 times 1.5 is 15 milligrams per milliliter times milliliter. Divide that by 20 milligrams. And I'm left with X is 0.75 or 3/4, but this one we can put in a decimal because we're using medicine, milliliters.